Swayam Prabha. Digital India. Educated India.
Welcome back, learners. The video is for the subject of Geography for the course of Bachelor's in Arts with Geography or Bachelor's in Arts with Honours in Geography. The video is for the paper of Climatology. Today we will be discussing Lecture 4 of Module 6, and the topic of the lecture is Thunderstorms and Tornadoes. The video is being recorded by Dr. Pallavi Upreti. The course coordinator and presenter for the video is Dr. Pallavi Upreti, affiliated to Department of Geography, Doon University. The academic expert and reviewer for the video is Professor Santosh Verma, Head of the Department, Department of Geography, SDM Government Degree College, Doiwala, Dehradun, affiliated to Shri Dev Suman, Uttarakhand University. The video is produced and presented under the project name DTH Swayamprabha Channels of MHRD, New Delhi, India. Hello learners, I am Dr. Pallavi Preti, Assistant Professor in the Department of Geography in Dr. Nityanand Himalayan Research and Study Center, Doon University, Dehradun, Uttarakhand. In our previous lectures, we have discussed various concepts which are associated with cyclonic conditions. We have discussed the tropical cyclones, the temperate cyclones, and weather conditions which are associated with them. In this particular video lecture, we will be discussing another important phenomena which is associated with cyclonic conditions, which is called as thunderstorm, and violent manifestation of thunderstorms in form of tornadoes. So we will be discussing all the concepts which are related to thunderstorms and tornadoes in this particular video lecture. So let's begin. In the due course of this particular video lecture, the learners will be able to understand various aspects associated with thunderstorms. So they will understand in general what thunderstorms are, and then what are the major areas around the world where the thunderstorms are experienced. What are the conditions for the development of thunderstorms, formation of thunderstorm, structure of thunderstorm, and stages of the development of thunderstorms, and what are the various weather conditions which are associated with thunderstorms, and finally we will be dealing with the classification of thunderstorms, and thereby we will be finally understanding what is the relationship between thunderstorm and tornadoes, and how tornadoes are the violent manifestations of specific conditions in a thunderstorm. So let's begin. What is a thunderstorm? Thunderstorm is a violent, short-lived weather disturbance that is almost associated with lightning thunder, dense clouds, heavy rain or precipitation in form of hail also sometimes, and very strong gusty wind movement. A thunderstorm is also known as electrical storm because of the presence of lightning in thunderstorm, and they are almost localized in character by the strong upward movement of air and large dense cumulonimbus cloud formation in which there is a strong updraft of air or wind. So they are primarily characterized by the strong upward movement of air, and also in the later stages when the thunderstorms become immensely extensive, in that case there is a strong downward movement of wind also. We will be discussing in the coming slides. But for the thunderstorm to develop, the presence of strong upward movement of air is very, very important. They are specialized cases of convection mechanism and consist of several convective cells characterized by strong updraft of air. So thunderstorms occur primarily in almost all the regions of the world which experience the special case of convective mechanism, but they are very rare beyond the latitudes of 50° north and 50° south latitudes. So in both the hemisphere beyond 50° latitudes, they are very rare. So they are not experienced in the higher polar regions of the world, and primarily the mid-latitudinal areas where warm and moist air from the tropical latitudes collide with the cooler air coming from the northern regions, which are mainly the areas of the formation of fronts also. These types of thunderstorms are created. So these are primarily found in the regions of turbulence, where you can see that the cold chilled air coming from the north is colliding with the warm air coming from the south. So they are primarily found along the margins of the tropical temperate regions of the world. Therefore, the mid-latitudinal areas are most prominent regions where the thunderstorms are experienced around the world. Thunderstorms primarily occur in cumulonimbus types of clouds which have extensive vertical extent. So why extensive vertical extents? Because these are formed in the regions where you have very strong updraft of air, which leads to the ascent of air to higher vertical heights in the troposphere, and primarily this type of setup is found in cumulonimbus type of clouds. So they have extensive vertical extent primarily because of the strong updraft of air, and they are usually accompanied by very strong winds and often produce very heavy rainfall, which is sometimes even followed by different types of precipitation also, like snow, sleet or hails. But some thunderstorms produce little precipitation to no precipitation at all, depending upon their location, depending upon the amount of moisture content in them also. And thunderstorms may line up in a series of bands, which is also called as squall lines. Thunderstorms are responsible for the development and formation of many severe weather phenomena in the atmosphere, and they impact a very large area in the mid-latitudinal regions of the world. Primarily, the damage that results from the thunderstorms is mainly inflicted by the downburst winds, large hailstones, and flash flooding caused by the heavy precipitation which is induced by this thunderstorm phenomena in the atmosphere. And strong thunderstorms are also capable of producing water sprouts and even tornadoes also in very specific conditions. So thunderstorms are basically violent weather phenomena, violent weather conditions which exist in our atmosphere, and they impact large section of the mid-latitudinal areas where they are associated with severe weather phenomena around the world. Now let's look at what is the extent, frequency, and the location of thunderstorms around the world. Just looking in the particular map, you can see that thunderstorms are most frequent in the areas between the Tropic of Cancer to Tropic of Capricorn, that is between the 30° north to 30° south latitude in both the hemispheres, and they are seldom seen beyond the 60° north and 60° south in both the hemispheres, because thunderstorm formation is strongly associated with the convective mechanism. Therefore, their intensity and frequency is also very high in the mid-latitudinal regions of the world. Also observe that nearly 100 to 80, that is the frequency of thunderstorms, is very high over the land surfaces in the mid-latitudinal area. So their most important area of development is over land surfaces. Why? Because land surface has the tendency to get heated more quickly as compared to water surfaces. So their frequency is high over the land surfaces. And as you move towards the polar areas in both the hemisphere, you can see that the thunderstorm frequency reduces immensely. So it has been estimated that at one moment there are approximately 1800 thunderstorms in progress throughout the world. So although thunderstorms occur most often in the tropical latitudes of the world, but there are certain cells, certain regions which are most frequented by thunderstorms. For example, you have the Florida Peninsula in USA and New Mexico, as you can see in this particular diagram, that the regions of the southern USA around Florida Peninsula, New Mexico region and Gulf Coast region of USA is highly prone to these thunderstorms. And then you have the Central American region, Gulf of Mexico and Caribbean Sea region in the Central America and South America region also. These regions of the world, because they are plateau regions of the world, they are immensely heated during the summertime period, and even during the winter time period also, the land gets heated very quickly. So these regions have very high frequency of these thunderstorms. Then in the Central America only, you have regions of Venezuela, Brazilian highlands, Central South American region also. And then as you can see that in Africa, their frequency is very high. Nearly 100 to 180 thunderstorms are experienced in a year in this particular region. Then you have Central East South African regions around Madagascar and in the West Indian Ocean region, which are most frequented by thunderstorms, followed by the South Asian region and Southwest Pacific Ocean islands. This particular region is also very high in the frequency of thunderstorms, and moderate thunderstorms are then active around the Central European Asian regions. So you have moderate to low thunderstorms which are occasionally experienced in the European regions also, primarily because these particular belt above 30 to 40 degree north latitude and south latitude is mostly experiencing the temperate cyclones, but sometimes these thunderstorms may extend to the southern limits of Europe also. So these are the regions of the world, and as you can clearly see here that thunderstorms are most often and most frequent in the regions around the mid-tropical latitudes of the world. But thunderstorms do not develop in any conditions of the world. There are certain specific conditions which leads to the formation of thunderstorms. So the main condition for the development of thunderstorms are, first of all, the region should be the area of high temperature. Thunderstorms originate mainly in warm hours during the summer season. Surface heating through the intense insolation causes convective mechanism resulting into updraft of air and atmospheric instability. So these are mainly experienced in the continental areas of the tropical latitudes where the insolation becomes very intensive. Hence, the convective mechanism is also very intense, leading to strong updraft of air. Because of this strong updraft of air, it leads to atmospheric instability. So existing high normal lapse rate in that particular region, then the adiabatic lapse rate ensures the upward ascent of the air leading to atmospheric instability. So as we have discussed in the previous module, also in module 4, if the normal lapse rate of any region will be higher than the adiabatic lapse rate, the rising parcel of air becomes unstable and it keeps on rising till the time it does not attain the same value according to the normal lapse rate. So since the normal lapse rate is very high, the rising parcel of air keeps on rising, leading to atmospheric instability. Then you have the ascending potentially unstable warm and moist air. So the existence of warm and moist air is also very important, which ensures the precipitation in that particular thunderstorm. Otherwise, it will not lead to precipitation. So the upward movement of warm and moist air is prerequisite condition for the development of thunderstorm. So if the air will be just warm but not moist, it will not lead to precipitation and it will be dry. But if the warm air is also moist, in that particular condition, the thunderstorm will be very strong and the updraft of air will keep on ascending till the time the condensation level is reached and precipitation occurs. So it may initially rise due to the convective mechanism or frontal condition or orographic barrier, but later on it ascends due to the adiabatic temperature change, wherein the temperature decreases very quickly as the parcel of air rises due to the existing higher normal lapse rate in the environment. Then you should have abundant supply of warm and moist air, which is ensured by the intense heating in these particular latitudes of the world. So existence of warm air found in the lower latitudes of the world is the primary reasons for the thunderstorm development in the tropical mid-latitudinal regions of the world. So their concentration is high in the tropical mid-latitudinal regions of the world, primarily because these areas experience very high temperature, which is the consequence of intense heating of the ground surface as part of intense insolation which is received in these areas. Then you have thickness of cloud. So one of the aspect which is related to the extensive thunderstorm development is also the great thickness of the cloud. So the great thickness between the cloud base and the icing level leads to the convection, which demarcates development and maturity and the intensity of thunderstorm in a particular region. So the greater the thickness of the cloud in the tropical areas, it will lead to more intensive development of thunderstorm in that particular region. So these are the various important conditions which leads to the development of thunderstorm in the tropical areas of the world. But within these conditions, the existence of warm and moist air is very important for the development of thunderstorms in the first go in these regions of the world. Now, how thunderstorms form? What is the mechanism for the formation of thunderstorms? Thunderstorms arise when the layer of warm, moist air rises in a large, swift updraft to the cooler regions of the atmosphere. So, because of intense insolation, when this particular parcel of air rises in a strong updraft to the higher regions of the troposphere, and during this process when it gets cooled down. So this is the prerequisite for the formation of thunderstorm. There the moisture contained in the updraft condenses to form towering cumulonimbus clouds and eventually the precipitation occur. So in this process there is the formation of vertical towering clouds which is called as cumulonimbus clouds, and in the process the rising air gets cooled down leading to precipitation. Columns of cool air then sink earthward, striking the ground with strong downdraft and horizontal winds. So followed by the updraft of wind, there is also the downdraft of wind when the thunderstorm development progresses. So you have a strong updraft of wind and then you have a strong downdraft of wind. So at the same time, electrical charges accumulate on cloud particles and lightning discharge occur when the accumulated electric charge becomes sufficiently large. So these thunderstorms are also characterized by the thunder and lightning, which is primarily the outcome of the accumulation of electrical charges in the cumulonimbus clouds. Lightning heats up the air as it passes through so intensely and quickly that shock waves are produced, and these shock waves are heard as claps and rolls of thunder. So thunderstorms are often accompanied by thunder and lightning and very loud claps and rolls of thunder. So on occasion of severe thunderstorms, they are accompanied by these swirling vortices and becomes concentrated and powerful enough to form tornadoes, which are again very violent and short-lived but violent manifestations of swirling winds around a region. Thunderstorms, when developed, depending upon their level of maturity, they can be divided into single cell, multi-cell, and supercell also. A thunderstorm may consist of either one convective cell or several convective cells which are characterized by the strong updraft of air. So when this particular air lifts up, while lifting, various convective cells are formed, and based on how intensively these convective cells are developed and how many they are in number, it leads to the formation of either single cell or multi-cell or supercell type of thunderstorms. And each cell passes through a phase of life cycle consisting of youth, maturity, and old age, and different cells in a thunderstorm may be in different stages of development at one point of time. So Based on various stages of thunderstorm development, it can be divided into youthful, mature, or old or dissipating stage. So let's discuss these stages one by one. Now, in the first stage, as you can see in the diagram also, the lifting of moist warm air into the atmosphere is the primary prerequisite condition, which can be induced thermally, advectionally, along the fronts or orographic barrier. So once, because of intense insolation, the ground surface is heated, the air parcel which lies above this ground surface is also heated, and it starts lifting. Cause of lifting of air can be due to various factors. It can be induced thermally, that is due to intense insolation, or it can be forced to rise due to advection or formation of fronts, or even because of the orographic barrier. But once it is initially lifted due to these pushing factors, it thereafter ascends primarily because of the adiabatic cooling. As adiabatic cooling continues, the air is forced to lift up because of very high normal lapse rate existing in the environment. So as the air rises up, the cooling of air at higher altitude forms cumulus cloud initially. As the water vapor condenses into liquid and latent heat of condensation is released, which again warms up the air, causing it to become less dense than the surrounding drier air and pushes it to further uplift. The air tends to rise in an updraft through the process of convection, and this process creates a low pressure zone within and beneath the formation of thunderstorm. So in a typical thunderstorm, millions of kilograms of water vapor is uplifted into the Earth's atmosphere during this process. So this is the first stage of the thunderstorm development. Now, the second stage is called as the mature state, wherein the warmed air continue to rise until it reaches an area of warmer air and can rise no further. So, the upward movement of this air or upward ascent of this air continues till the point where the temperature of this air parcel becomes equal to the temperature of the surrounding atmosphere, and in this particular case that limit is the tropopause, because it can no longer rise further beyond the tropopause. So as it reaches tropopause, it is forced to diverge in the opposite direction, creating the very specific characteristics of cumulonimbus cloud, which has a canopy type of cauliflower structure, and it gives shape to that cauliflower type of structure, which is broader from above and it is tapering downwards. Once the cumulonimbus clouds are formed, it leads to copious precipitation also, because the air after reaching these heights also condenses immensely, leading to heavy precipitation. If the updraft is strong enough, the droplets are held aloft long enough to become so large that they do not melt completely but fall as hail. Because of the immense air which is coming from below, sometimes even after condensation, the water droplets are held in suspension and they do not fall and become bigger and bigger, leading to the formation of chunks of ice, which are then difficult for the ascending air to hold on, and they fall as chunks of ice, which are called as hail. While the updraft is still present, the falling rain drags the surrounding air with it, creating a strong downdraft as well. So now in the mature stage, you have updraft as well as the downdraft, because the precipitation, whether it is in form of rain or hail, it is dragging these winds downward with it when it is falling to the ground. So you have strong updraft as well as the downdraft in the mature stage. So the simultaneous presence of both an updraft and downdraft marks the mature stage of the storm and produces extensive cumulonimbus clouds. So you have continuous updraft of air as well as the downdraft of air, which is making the cumulonimbus clouds bigger and bigger with the very distinctive canopy, which is called as its enveil. Now, during this stage, considerable internal turbulence can occur, which manifest as strong winds, severe lightning, and even tornadoes. So, because of this intense updraft and downdraft of winds, and also because the structure has vertically extended to greater heights, it is also affected from the movement of winds coming from different direction. So, it can lead to changes in the wind direction. Sometimes they may also become circular, and it may also lead to severe lightning in the thunderstorm. And sometimes when the thunderstorms becomes very extensive and gains a circular motion, and it also touches the ground surface, it leads to violent manifestation in form of tornadoes, which we will just discuss in the coming slides. So typically, if there is a light wind shear, what will happen? That the updraft will gradually die off and the dissipating stage reaches. But if there is very high wind speed, and if the downdraft and updraft is very extensive, then the storm may become very mature. Sometimes it becomes immensely developed supercell also, and it develops very violent conditions which is accompanied by tornadoes. So if there is little wind shear, it is not able to sustain itself. But if the wind shear is very extensive, the updraft is very strong, it takes time for the storm to die off, and by that time it dies off, it becomes very violent, it becomes extensive, leading to destructive weather conditions in the region where they develop. So after the second stage, you have the third stage, which is called as the old stage or dissipating stage of the thunderstorm. And in this dissipating stage, the thunderstorm is dominated by the downward movement of winds, which spreads over the ground surface. The downdraft pushes the thunderstorm towards the ground, hits the ground, and it dies off gradually. So this phenomena is also called as downburst. While in the mature stage, you have a very extensively developed updraft with the downdraft. And in the first stage, you had a very developed updraft. Unlike both those stages, the first stage and the second stage, in the third stage, you have a very extensively developed downdraft, which at one point also overshadows the updraft, leading to the dissipation of the thunderstorm. This phenomena is called as downburst because the cool air hits the ground and the thunderstorm dies off. The cool air carried to the ground by the downdraft cut off the inflow of the thunderstorm. The updraft disappears and the thunderstorm dies off gradually. So the thunderstorm in an atmosphere with virtually no vertical wind shear weakens, and as soon as they send out an outflow boundary in all the direction, which then quickly cuts off its inflow, and relatively warm moist air which was flowing and sustaining the updraft is cut off, and it kills the thunderstorm's further growth. Now, the downdraft hitting the ground surface also creates an outflow boundary, and it can cause downburst, which is a potentially hazardous condition because you have high speed winds which are descending from the upper regions of the atmosphere towards the ground surface. So if these type of condition exist, these regions are very hazardous for flying of aeroplanes also, and it may lead to a disaster if not considered in these particular regions of the world. So you have three stages. First stage of the thunderstorm, where the updraft begins, warm air starts ascending, leads to the formation of cumulus clouds. Then you have the second stage where you have very extensively developed updraft along with the downdraft. And then in the third stage, the downdraft overshadows the updraft, leading to the cutoff of the supply of warm moist air which was maintaining that updraft, and the thunderstorm dies off. So this is the diagram of the extensively developed thunderstorm, and it clearly represents the structure of thunderstorm, where you can see that it has a strong updraft which is a warm, moist air ascending upwards, and after reaching somewhere in the upper regions of the troposphere, hitting the tropopause, which is the uppermost boundary of the troposphere, it is forced to diverge in the opposite direction, creating a canopy-like structure, which is called as its anvil. And then, because there is immense condensation which occurs in the upper regions of the troposphere, it leads to the precipitation. So if the updraft is not able to hold the water vapors in the atmosphere, they generally fall down in form of precipitation, and the precipitation can be in form of rain, hail, or snow or sleet, depending upon the intensity of the thunderstorm. And while the precipitation is taking place, it drags down the air along with it, leading to the formation of cool downward draft. So you have extensively developed warm draft and cool draft. But once this cool draft becomes very, very extensive, sometimes the supply of the warm air is also cut off because of the extensively developed cool down draft, and it leads to the dissipation of thunderstorms in the later stages, and finally the thunderstorm clears. Variable weather conditions are associated with the development and progression of thunderstorms. While rainfall is one of the most prominent outcome of thunderstorms, where heavy rainfall of short duration is experienced during the development of thunderstorms, which is also accompanied by variable forms of precipitation at times. For example, you have hailstorms also. So when the condensation occur at higher heights below the freezing points, ice particles are formed, and when the updraft of the thunderstorm is intense, these big chunks of ice particles are kept in suspension. But as the intensity of the updraft reduces, these hailstorms are released to ground surface with higher intensity. So you have hailstorms as one of the significant weather conditions, and followed with all these precipitation variables, you have lightning and thundering also as one of the primary characteristics of thunderstorms, wherein the lightning is developed mainly because of the electrical discharge centers which are developed in a mature thunderstorms due to steep electrical potential gradient between existing positive and negative electrical charges in a cloud, and this leads to the formation of lightning. Thus, the lightning effect is created in a thunderstorm because of the steep electrical potential gradient between existing positive and negative electrical charges. But it is important to note that the lightning effect is only produced in a very, very extensively developed thunderstorm where the vertical height of cumulonimbus cloud is very thick. Followed with lightning, you have thundering also, which is a sound produced in the cloud due to sudden rapid expansion of air column caused by the intense heat resulting from lightning stroke, and vibrating pressure waves due to expansion of air column is called as cloud thunder. So you hear sudden claps of thunder which are caused because of the vibrating pressure waves created due to sudden expansion of air column in a vertically towering cumulonimbus cloud. Besides this, you also have squalls, which are downward movement and divergence of cold air at the ground surface, and which is generally accompanied by heavy precipitation, mainly produced in the mature phase of thunderstorm, and they are accompanied by heavy precipitation. So extensive squall lines are developed in a mature thunderstorm, which represents area of downdraft and precipitation. Besides this, you have variable wind movement also as the thunderstorm progresses. While the primary wind movement is mostly associated with the upward movement and downward movement of the air, but when the thunderstorm develops extensively and gains a very immense vertical height, the movement of air coming from different directions as the altitude increases, it leads to the circular motion of winds also in thunderstorms, and these winds sometimes develop and attain a gale force, leading to dramatic changes in the weather patterns. So these are all the weather conditions which are associated with the development and progression of thunderstorm in any region. Now coming to the classification of thunderstorms. Thunderstorms are generally classified on the basis of their mode of origin, lifting factor and mechanisms. So one type of classification we have already studied in the third and fourth slide of this particular video, where we have said that thunderstorms pass through various stages, and depending upon how mature a thunderstorm is, it can be single cell or multiple cell or a supercell thunderstorm. But besides that, thunderstorms can also be classified based on the mode of origin, their lifting factor, and mechanisms associated with them. So based on these factors, the thunderstorms are primarily divided into air mass thunderstorms and frontal thunderstorms. And under the air masses category of thunderstorms, you have thermal or heat-induced thunderstorms. So as the name suggests, they are primarily developed because of the temperature-induced conditions, and they are mostly localized and originate due to intense heating of the ground surface, especially in the summer season. So because of intense insolation, the ground is heated, which leads to the strong updraft of air, leading to the formation of thunderstorms. Besides the thermally induced thunderstorms, you have orographically induced thunderstorms. And as the name suggests, these type of thunderstorms originate because warm, moist, unstable air strikes the mountain barrier and it is forced to rise up hurriedly. And in the process, copious rainfall takes place, leading to formation of thunderstorms. And followed by thermal and orographic thunderstorms. You have advectional thunderstorms, and again, as the name suggests, they are generally used due to the convective mechanism in the air, which is primarily aided because of the increased normal lapse rate in the environment, and consequently the air is forced to move upwards, creating the atmospheric instability conditions, and it leads to the formation of thunderstorms in the process. Besides air mass thunderstorms, you also have frontal thunderstorms. So as the name suggests, these types of thunderstorms are primarily developed in the frontal areas of the world. And as we have read in the previous videos, we have two types of fronts. We have warm front and we have cold fronts. So the thunderstorms which developed along the warm front areas are called as warm front thunderstorms. But because the warm front is a gently sloping boundary, the warm air, when rises up along this gently sloping boundary, the air is not having that strong updraft, because of which the thunderstorms which develop along these warm fronts are comparatively weaker to the thunderstorms which develop along the cold frontal regions of the world. So warm front thunderstorms are mostly weak in nature and they die off within a short span of time. Now coming to the cold front thunderstorms, because the cold front is intensive, very steep front, it leads to the aggressively rising of warm air along the cold front. Therefore, the thunderstorms which are developed in the cold frontal regions of the world are more extensive, they are stronger as compared to the thunderstorms which develop along the warm frontal regions of the world. So now I want to discuss a special category of storm, which is a supercell storm. So as we have already discussed that we have various stages of thunderstorm development. It can be multiple cell, it can be single cell, and it can be a supercell storm. So because of intensive insolation at the ground surface, the air near the ground surface becomes very unstable, and this unstable warm parcel of air starts rising, and while it is ascending, various convective cells are formed, and these convective cells are generally located in close proximity to one another. But these convective cells may be in various stages of development. While few can be still in the single stage of development, they can be in the youthful stage of development, other can be in the mature stage of development, while few have already crossed the various stages of development and they are in the stage of dissipation. So these convective cells are continuously ascending, and once they reach the upper limit of the troposphere, that is the tropopause, they hit the tropopause, and because they can no further rise beyond this point, they are diverted into opposite directions. And at this point, these particular convective cells and the rising air in this updraft condenses, and it leads to the formation of hails, which remain suspended in the air because of very extensively developed warm updraft. And this type of thunderstorm create most intensive anvil. Anvil is basically the canopy type of structure which is developed in the cumulonimbus clouds, and it represents a very mature stage of thunderstorm. So until the warm updraft is very extensive, all the condensed water vapor, they remain suspended in air. But as the warm updraft loses its shear intensity, these condensed water vapor fall towards the ground, and while they are falling towards the ground, they drag the air which is accumulated in the upper parts of the troposphere with them, leading to the formation of cold downward draft. And this cold downward draft is also very intense. So a supercell is actually characterized by very strong updraft of air which is warm, and then it is also accompanied by the very strong cold downward draft. And these storms are most intense type of thunderstorms because they form an anvil, which is a canopy type structure. The updraft speed in a supercell can exceed to 40 meters per second and are capable of suspending big hailstones also with very heavy downpours. So this downward draft is also extensive, and it has a capability of even suspending very big hailstorms along with it. And sometimes the intense downdraft also inflict damaging winds because the shear wind intensity in these downdrafts is very high, and it may also lead to macro bursts or microbursts depending upon the intensity of the thunderstorms. And sometimes the sheer intensity of this downdraft leads to the formation of tornadoes. So a supercell storm has a very extensively developed updraft as well as the downdraft, and because it is vertically so extensive and the winds are coming from different direction at different altitude, it leads to the rotatory circulation also in these supercell storms, which is one of the most important characteristic features of this supercell storm. So they are basically rotating huge immense thunderstorms with very high intensity of updraft and downdraft. So when these updraft and extensively developed downdraft of a storm becomes organized and twist around and reinforce each other, it leads to the formation of circular wind movement also within these extensive systems, which result into a very long-lived storm which is called as a supercell storm. And these supercell storms under specific inclusive conditions are also capable of generating destructive climatic conditions like the formation of tornadoes. So tornadoes basically are the funnel type extensions from the base of the thunderstorms, and when this rotating funnel of air touches the ground, it leads to very violent damaging manifestations of these thunderstorms, which are called as tornadoes. So let's just discuss tornadoes now. So tornadoes are basically violent manifestation of extensively developed thunderstorms wherein the downdraft becomes so extensive that it leads to the formation of tornadoes. So tornadoes are violent spinning thunderstorms, and they are violently rotating columns of air having funnel shape extending from the base of the thunderstorm towards the ground, and its other end touches the ground through a narrow column of air. So they are kind of funnel type of structures which are extending from the base of the thunderstorm towards the ground surface, and because the downdraft is so extensive, it leads to the rotating wind movement near the ground surface and drags the air near the ground surface into very high wind velocity, giving a funnel type of violently spinning structure which is called as a tornado. And these funnel-shaped storms are smallest but most destructive atmospheric systems, wherein the wind velocity may range from 65 miles per hour to 200 and more miles per hour, depending upon the intensity of the thunderstorm which manifests them. Therefore, all the tornadoes starts from the thunderstorms, but it is not necessary for all the thunderstorms to produce tornadoes. As initially told you in the previous slides, that supercell thunderstorms have only the capacity to produce these violent type of weather conditions which are called as tornadoes. So they are produced from rotating thunderstorms which are called as supercells. So the essential condition for the storm to form tornado is the presence of cool, dry air at middle levels in the troposphere, overlaying a layer of moist, conditionally unstable air near the surface of Earth, creating a strong updraft. So the strong updraft is also very important for the formation of tornado along with the thunderstorm. As you can see in the diagram also, from the base of the thunderstorm, due to the strong downdraft and updraft, a section of funnel extends to the ground surface, leading to the formation of tornadoes. And they are very, very violent weather systems which damage the life and property if they develop in any region of the world. So most of the tornadoes are formed when a strong updraft acts to concentrate atmospheric rotation or spin into a swirling column of air, and the swiftly inward moving air is caught into a vortex of the storm and is rapidly lifted, and it cools adiabatically, forming violent thunderstorms which are called as supercell thunderstorms, as we have discussed. So air rising in a thunderstorm continue to rise, and it begins to spin when it is affected by the winds blowing in different direction in different altitudes. So because this column of air and this formation of cumulonimbus clouds has a great vertical extent, it is affected by the winds blowing in different directions in different altitudes, also giving it a spinning motion. And as the spin-up of the mesocyclone continues, its rotation action begins to reorganize the airflow in the updraft. And this very violent, long-lived rotating thunderstorm contains circulation aloft that goes upward through the storm and downward through the ground. So you have two types of funnels which are going out. One is moving upward and the other is moving downwards. So due to violent convection of conditionally and convectively unstable column of ascending air, a funnel cloud forms and extends towards the ground. So because of extensive downdraft, the funnel extends towards the ground surface, and when the air in the storm sinks to the ground and spreads out, in the process, gust of warmer air rises and gust of cooler air sinks as they blow across the land. And if there are enough rising and sinking of these gusts, the air near the ground surface also starts spinning. Now, as the spinning air near the ground speeds up as it is drawn inward toward its axis of rotation, the center of tornado is characterized by the extremely low pressure. Due to such steep pressure gradient, the wind rushes towards the center of low pressure with great velocity, generally extending between 600 to 800 kilometers per hour. So in these conditions, the spinning air near the ground is also drawn inwards towards the axis of rotation, and rising air from the ground pushes up on the swirling air and tips it over, leading to the formation of funnel structure. The funnel of swirling air begins to suck up more warm air from the ground, and it causes the air on the ground to rotate more strongly and begins to rip up the parts of the earth because of extreme wind velocity and rotation. The funnel grows longer and stretches towards the ground, and when the funnel cloud meets the churning air near the ground, it becomes a tornado. So, for your visual reference, just see this small clip where the tornado formation is taking place. As you can see in this particular video, that the funnel of air is extending towards the ground surface, and as soon as it meets the spinning air of the ground, it leads to the formation of funnel of wind, which when touches the ground is called as tornado. So you can see a very short time lapse is shown by James Hammett of the development of tornado near Wyoming in 2018. So it brilliantly showcases all the phases of the development of a tornado. In the initial stages, you can see it is just a protruding funnel towards the ground surface, and as it meets the rotating air of the ground, it creates a funnel whose one end is attached to the base of the thunderstorm and the other end is attached to the ground surface. And the end which is attached to the ground surface creates havoc on the ground surface, and because of the very high wind velocity, it is highly destructive in nature and it rips apart whatever comes in its path. So you can say that to be classified as a tornado, the rotation must exist in both inside the thunderstorm and at the Earth's surface. So while its one end should attach the thunderstorm, the other end of the tornado should be attached to the ground surface. So as the rotating column of air touches the ground, it becomes a tornado. And this rotation may occur with or without visible funnel of cloud. And once formed, the tornado tends to move over the ground surface, and the movement of the tornado is determined by the motion which is generated by the overlaying thunderstorm. So the average tornado moves at a speed of about 12 to 13 meters per second. So at this very high speed, they destroy everything which comes into their path. While they are characterized by very high wind velocity, the wind which is swirling and churning inside the funnel of air of tornado, and that churning funnel of air moves in a certain direction which is directed by the development of the overlying thunderstorm. So whatever comes in their path because of very high wind velocity, they rip them apart. So due to raging wind speed, the tornadoes cause massive destruction on ground, ripping everything which comes into their path. And tornadoes are also rated between 0 to 5 on the enhanced Fujita scale. So the scale which is used to rate the intensity of tornado is called as enhanced Fujita scale, where 65 miles per hour is generally termed as a low intensity tornado, and when the wind speed is more than or equal to 200 miles per hour, it is generally a category 5 tornado in enhanced Fujita scale, and it is very, very violent and destructive. As you can see that enhanced Fujita scale 5 category tornado hit Greensburg area in Kansas City with a wind speed of 320 kilometers per hour, and it destroyed everything which came along its path. And you can also see an aerial view of the destruction which is caused by a massive tornado that struck the area in the south of Oklahoma City in USA. So the areas which experience these violent weather phenomena in form of tornadoes face massive destruction in terms of life and property. So summarizing the video now, thunderstorm is a violent short-lived weather disturbance that is almost always associated with lightning, thunder, formation of dense cloud, heavy rain accompanied by hail and strong gusty wind formation also. And they are primarily localized storms which are characterized by strong updraft of air, and they are formed in immensely developed vertically towering clouds which are called as cumulonimbus clouds, and they are mostly experienced in the mid-latitudinal regions of the world, in the tropical areas of the world where the intense insolation induced convection is immense. So thunderstorms are basically the outcome of intense insolation, which is followed by convection and convective mechanism, upward ascent of air leading to the formation of thunderstorm. And based on their extent, they can be single cell, multi-cell, or even supercell, and they have several stages of development, which is divided into youth, maturity, and dissipating stage. And on occasion, several thunderstorms are accompanied by swirling vortices of air that becomes concentrated and powerful enough to form swirling funnel type rotating structures, which are called as tornadoes. And these are violently spinning thunderstorms whose one end is attached to the ground and other end is attached to the base of the thunderstorms. And these tornadoes represents very violent manifestations of the extensively developed thunderstorms, primarily the supercell thunderstorms. And due to raging wind speed, they cause massive destruction on ground along their path of movement. So I hope this video was clear enough to describe all the aspects of thunderstorms, related weather conditions, thunderstorm stages, their development, and their manifestation in form of extreme weather condition and disaster like tornado. So I hope the video was informative. Thank you so much.